Yo, yo, yo! Welcome back. Okay, we're doing Math Quest 2012, Maths B, Chapter 8 review, questions 13, continuing from our previous videos. Okay, on question 13, find the area bounded by the curve g of x, which is 4 minus x, all bracket, multiplied by 6 plus x, all bracket, and the x-axis. Alright, so this is literally g of x and the x-axis, and use the graph at right to answer question 14 and 15. Oh, because that's now I thought that was the same as 13, but second thought, I don't think that's the same. Okay, let's just do 13 for now. All right, so let's let's go get some visuals. All right, let's go to decimals and plot the graph. All right, so here's the graph. Looks like a normal parabola. Okay, so not too much difficulty, I believe. Let me just double check with the question. So g of x and the x-axis, right, bounded by the area. So we are looking for all this. All this. Alright, so let's just do it. So we're integrating from -6, right, this point, to this point, to 4, positive 4. Alright. Function, oh no, remember, top minus bottom, integrated with respect to x. Okay, now top is our g of x function, which is 4 minus x bracket 6 plus x close bracket, minus this bottom function is the x-axis, which is y equal to 0, so it's a 0. Integrate with respect to x. So this is a 6. That is just, alright, we can expand the brackets here. So 4 times 6 is 24, positive. 4 times 6 is plus 4x. Negative x times 6 is negative 6x. Negative x times x is negative x squared. Alright, let's rearrange it. With x squared being first. Positive 4x minus 6x gives negative 2x plus 24. And then integrate with respect to x. Alright, finally, we can start integrating. Oops, no more integral sign. So we get negative x cubed over, negative x cubed over 3 minus 2x squared over 2 plus 24x. From -6 to 4. Alright, tidy things up a bit. Minus x squared plus 24x. -6 to 4. Alright, let's start subbing the number ins. So we get 4 to the power of 3 over 3 minus 4 squared plus 24 times 4. Minus negative 6 to the power of 3 over 3 minus negative 6 squared plus 24 times negative 6. Woohoo! Alright, let's do one by one. So we get, oh, forgot, there's a negative there, don't forget that. All this silly little error can be made by those, forgetting the signs. Negative, positive, don't make those silly mistakes. It's very costly. Okay, so this one becomes negatives 4 cubed. Oh, what's that? What the hell is that? Okay, becomes negative 4 cubed is what? 64 over 3. Alright, minus 4 squared is 16 plus 24 times 4 is 96. Alright, minus, now, 6 cubed is 216, I believe. Yep. So, but negative 6 cubed is negative 216, right? And so negative becomes positive. So it's just 216 over 3 minus negative 6 squared is 36, right? Plus 24 times negative 6 is negative 144. Alright, let's do all the numbers inside the brackets. Let's calculate. So negative 64 over 3 minus 16 plus 96 give us 58 and 2/3. Alright, and then 216 on 3 minus 36 plus negative 144 give us negative 108. So minus negative 108. Alright, because there's a bracket there and a negative sign there. Okay, so that means plus. So 58 on 2 and 2/3 plus 108 give us 166 and 2/3 unit square. And that is the answer for question 13. Yeah? Whew. Okay, now use the graph at the right to answer question 14 and 15. You know, buy one, get one free. Okay. Wow, that's cold. Okay, question 14 is a multiple choice. So the two graphs intersect where x is equal to, so we're trying to find where they intersect, right? We're trying to find this point, the x value, and that point, the x value. Right. And we've got the two equations. One is linear, one's a quadratic. Now, when they intersect, that means they are equal, right? Remember, when two graphs intersect, that means at the point of intersection, they are equal, the two graphs. So, question 14, I'll do it here. So the equation is y is equal to 2x, is it? Plus 3. 2x plus 3. The other equation is equal to y equal to x squared. So at point of intersection, both function are equal. Okay, so therefore x squared is equal to 2x plus 3. And now we can move everything to one side, giving us a quadratic equation, right? And all I have to know is plot this particular quadratic equation and find the root. And those roots will be my x coordinate of the intersection. Yeah, alright, let me use decimals. Alright, so we've got the plot here, we've got the graph here, so these are the two roots, or x-intercept. So it's -1 and 3. So if we go back to question 14, so that point must be -1, whatever the y value is, and then 3, and whatever the y value is. So it is -1 and 3, so which is B. -1 and 3. Easy. Okay, number 15. Okay, so it's the same graph. Alright, the area bounded by the two graphs is equal to. Alright, so now we're looking for this area. Good, we just got our x domain, so we can just go definite integral from -1 to 3. Great. So, integrating from -1 to 3, top minus the bottom. Integrated with respect to x. That gives us, alright, I'll have to go back to the graph. Which one's on the top? It looks like the linear is on the top within that given area. Alright, so the linear minus the parabola function. So with the linear, was it 2x plus 3? Yep, 2x plus 3. Just double check. Yes, 2x plus 3. Minus the bottom one, which is the x squared. Integrated with respect to x. Alright, expand the brackets. You get 2x plus 3 minus x squared. integrate it with respect to x. Alright, nothing else we can do, and then let's integrate. So 2x becomes 2x squared over 2 plus 3x minus x cubed over 3 from -1 to 3. Alright, tidy things up a bit. X squared, that's 2x squared over 2 is just x squared plus 3x minus x cubed over 3 from -1 to 3. Alright, so let's put the numbers in. So first we got 3 squared plus 3 times 3, well literally just another 3 squared, minus 3 cubed over 3 minus -1 squared plus 3 times -1 minus -1 cubed over 3. 3 squared is 9 plus 3 is another 9 minus 3 cubed is 27 divided by 3 is 9 minus -1 squared is +1 plus 3 times -1 is -3. -1 cubed is still -1, so it's negative become positive, positive 1/3. So we get 18 minus 9, which is just 9, minus whatever in this bracket is. So this is 1 minus 3 gives you -2. -2 plus 1/3 gives you -1 and 2/3. So it gives you 9 plus 1 and 2. 9 minus negative is just plus, so it's 10 and 2/3 units square. Alright, let's see, is that one of the answer in there? 10 and 2/3. Woohoo! There we go. Alright, so that's question 15. Done. Alright, let's go for the last one in this video, probably. Yeah, we should have time for one more. Okay, so let's go to question 16. Alright, 16. Calculate the area between the curve y equal to 2 cosine x and the line y equal to -x between x equal to 0 and x equal to pi over 2. Alright, let's get some visuals. Alright, here's the graph. Got some visuals here. So we're calculating the area between the curve y equal to 2 cosine x and y equal to -x from x equal to 0 to x equal to pi over 2. So literally all this area. Yeah, all this. Because we're not doing with the x-axis, we're not doing anything, we're doing the area between the two curves. From 0 to x equal to pi over 2. Alright, easy, let's integrate. So it's from 0 to pi over 2. Right? So it's top minus bottom. Integrate with respect to x. Alright, so the top function would be the cos function, right? 2 cosine function. So it would be 2 cosine x minus the bottom function, which is -x. And that gives us 2 cosine x plus x. Integrate with respect to x. Yeah? Alright, let's integrate away. So 2 cos x become 2 sine, positive sine x, then divided by the derivative of inside the bracket. The derivative of inside the brackets. Remember, you have to divide it by that if you're integrating cosine functions and sine functions or trigonometric function. Okay, so 1 plus x squared over 2 from 0 to pi over 2. Alright, let's put the values in. So we get 2 sine pi over 2 all over 1 plus pi over 2 squared divided by 2. Right? Minus 2 sine 0 over 1 plus 0 square over 2. Now, sine 0 is 0. So that makes the whole thing 0. And that makes the whole thing 0. So it's like a boom, boom, boom. Okay. And this is what we left on the left on this first bracket here. So pi over 2 is 90. Sine 90 is 1. So just 2 times 1 over 1, which is 2. Pluses. Now, pi over 2 square is just pi over 4. Pi square over 4. Right? And then you divided that by 2 again. That gives you 2 plus pi square over 8. Yeah? And okay. And that's it. That's the area. 2 plus, yeah, that's the area. Alright, I'm just going to leave it like that. I don't want to, you know, put in decimal, make it an exact values. 2 plus pi square over 8. Right? Yep, that's it. Nothing more. Okay, unit square. Unit square. Okay, that's the answer for question 16. Yeah, suppose nothing too hard. And let's just stop there, alright? So that's from 13 to 16. So question 13 to 16. So we're going to take a commercial break, alright, and come back with question 17 and 18, I believe. So those two are the last modeling problem solving of the chapter we viewed. Alright, I'll see you then.